Now, chapter number 9, illustrations. A structural steel rod has a radius of 10 millimeter and a length of 1 meter. 100 kilonewton force stretches it along its length. Calculate the stress, then elongation, strain on the rod. Young's modulus is given. Okay. Now, first of all, stress is nothing but force upon area. Now, this is a cylindrical rod, so its cross section will be a circular cross section and the area of cross section will be pi r square. If you write all the values, okay, here the radius is given 10 millimeter, so it is 10 into 10 raised to minus 3 meter. Okay, convert everything in mks and calculate, simplify it. You will get the value of stress to be 3.18 10 to the power 8 Newton per meter square. Now, as you know, Young's modulus is stress upon strain, and strain is change in length upon original length. Okay. Now, make delta L as a subject of formula. You can write Y is equal to stress multiplied by the original length upon delta L. And if you make delta L as a subject of formula, you will get stress into original length upon Young's modulus. Put all the values, okay, which we have, okay, and simplify. You will get delta L to be 1.59 millimeter. Now, strain is change in length upon original length. Okay, just place the values of change in length. Original length is 1 meter. So, strain will be 1.59 into 10 to the power minus 3. And if you want to find it in the percentage, just multiply it by 100. You will get 0.159 or approximately 0.16%. Okay. Now, example number 9.2. A copper wire of length 2.2 meter and a steel wire is having the length 1.6 meter, both of diameter 3 millimeter are connected end to end. When stretched by a load, the net elongation is found to be 0.7 millimeter. Obtain the load applied. Young's modulus for copper and steel are given. Okay. Now, the radius is given, that is 1.5 into 10 raised to minus 3 meter. Why? Because the diameter is 3 millimeter. Now, length of copper wire we write LC as 2.2 meter, length of steel wire as LS, that is 1.6 meter. Now, total increase in the length is delta LS plus delta LC, and that is 0.7 into 10 raised to minus 3 meter. Now, Young's modulus, as you know, it is nothing but stress upon strain. Okay, strain is delta L upon L. Okay, so you can write stress as Young's modulus multiplied by delta L upon L. Now, stress on both the wire is same because load applied at the end will have the same value of the stress which is produced. Okay, force upon area will be same. Okay, so we can write Young modulus for copper into change in length of copper divided by original length of copper wire is equal to Young modulus of steel multiplied by change in length of steel upon original length of steel. Now, delta LC upon delta LS can be obtained. Okay, just shifting the different terms on right hand side and left hand side, place their values. Okay, you get delta LC upon delta LS to be 2.5, and if you write, say, delta LC is equal to 2.5 delta LS. Okay, then this value can be substituted in the equation which we have already written here in this equation. Then the value of delta LS and delta LC can be obtained. Okay, very easy to do it. Okay, here it is taken in a different way. Here componendo is taken, so that delta LC plus delta LS upon delta LS. Here in the denominator there is 1, so 1 is added in the numerator. Okay, and this delta LC plus delta LS is taken to be its value to be 0.7 into 10 raised to minus 3. So delta LS you can get easily 2 into 10 raised to minus 4. Okay, and from this delta LS you can find the value of delta LC also. Okay, that is 5 into 10 raised to minus 4 meter. Now Young's modulus is stress upon strain, so stress is equal to Young's modulus times the strain. Okay, stress is force upon area, as you know. So instead of stress, it is taken to be force upon area, Young modulus into strain. So force will be Young modulus into strain into area. Okay, now this all values are given. Okay, you can take the strain of the steel wire. If you are taking the Young modulus of steel wire into pi r square, place the values. Okay, so force you will get, that is about 17.6625 into 10 raised to 1. So we can write 1.8 into 10 to the power 2 Newton. Okay, now you can use the copper wire, or we can say data of the copper wire. From this formula load can be calculated. Okay, another method is also there. Suppose connection of copper and steel wire is stretched by the load W. Elongation of the both wire, that is copper and steel, will be because of this weight. Okay, so this way also you can understand that the copper wire and the steel wire are attached and the load is attached at the free end. Okay, so Young's modulus you can write stress upon strain, that is weight upon area, delta LC upon LC. Okay, so weight into LC upon A into delta LC you can write. Hence increase in the length of copper wire, that is delta LC. Okay, can be written as weight into LC upon A into Young modulus of copper. Then similarly for the steel wire can be written. Okay, now increase in the length of the system is given. So total increase is delta LC plus delta LS, that is 0.7 into 10 raised to minus 3. Now place these values here, that of delta LC and delta LS. Okay, W upon A is common. Okay, write all the other values and simplify. Okay, make W as a subject of formula. Okay, W as a subject of formula by writing all the other values. Okay, area is nothing but pi r square. So pi r square is taken here. Okay, W is made subject of formula. You will get W to be 1.8 into 10 to the power 2 Newton. This is the another method of doing the sum. Okay. Now example number 9.5, the average depth of Indian Ocean is about 3000 meter. Calculate the fractional compression, that is delta V upon V of water at the bottom of the ocean. Bulk modulus of water is given, it is 2.210 to the power 9 Newton per meter square. G is 10 meter per second square. Density of water 10 to the power 3 kilogram per meter cube. Okay. Now pressure exerted on the bottom of the ocean is H rho G, or we can say rho G H. Rho is the density, G is the gravitational acceleration, and H is the height. Okay. Now pressure is force per unit area. Write all the values of height, rho, then we have the value of G. Okay, just place them here in this particular equation. Okay, Force upon area you will get 3 into 10 raised to 7 Newton per meter square. Now bulk modulus is nothing but stress upon volume strain, that is stress upon delta V upon V. Now bulk modulus is given to us. Okay, bulk modulus is known to us. We can find delta V upon V by making it as a subject of formula. So delta V upon V is equal to stress upon bulk modulus. Okay, place the values here instead of stress. Whatever value which we got, 3 into 10 raised to 7. Okay, that value is placed here. Bulk modulus is given. Just simplify, you will get the value of delta V upon V, and if you multiply that value by 100, okay, you multiply this value by 100, then you will get the percentage change in volume, and that is 1.36%. Okay, calculate these illustrations in your fair book, notebook, and try to just practice them. Thank you very much.